All right, so in this video, we're going to look at some examples of how to find some of those other angles that will result in the same cosine, sine, or tangent functions. So we're going to look at an example. I'm going to work through an example here with radians and using the cosine, and then I'll just have a couple of problems here that you can work through on your own and kind of check your answers, and then hopefully that'll do us pretty well. So first problem we'll look at together here, we're going to name three angles between negative 2 pi and positive 2 pi. So it's given us a window where we want to find our angles and a sort of upper and lower bound, and with the same cosine as 5 pi over 3. So 5 pi over 3, uh, so the cosine of that angle is going to be the x coordinate for that angle. If you want to think about that in degrees, just to put a handle on it, that would be about 300 degrees, or not about. That's exactly 300 degrees. So, how are we going to approach this? Well, first thing I'm going to do is just reference my identity, right? So the cosine of an angle is just equal to the cosine of the negative of that angle. So I can just okay, well, if positive 5 pi over 3 is has this cosine, then the cosine of the negative 5 pi over 3 is going to have the same value. So that's all I have to do. Just tack on the negative 5 pi over 3. That's it. So that's my first answer. Now, there are going to be two more. If I add, um, excuse me, right? So that's the only one I can find using the identity. The other method that I have is the adding or subtracting 360 degrees or 2 pi in the case of a radians problem, and that's what I have here. So we're going to need to add or subtract 2 pi from this value here. Now, if I add 2 pi, I'm going to be outside of my window, right? If I start with a positive number and then add 2 pi, it's going to be bigger than 2 pi. So I'm going to need to subtract. And so to do that, again, this might be a non-calculator question on a test. So if IB were asking you this question, it could be a non-calculator problem. So we want to be able to make sure we can do the arithmetic here and feel comfortable with that. So what I have is 5 pi over 3. And so I can add or subtract to find another one. But in this case, we already identified we're going to subtract 2 pi from this angle to to find my other value here. Now, working with fractions can always be a little tricky. So I'm going to rewrite this 2 pi as 6 pi over 3 to kind of conceptualize the arithmetic. Now I have a common denominator. Hopefully that's clear that 6 pi over 3 is the same as 2 pi. So if I just carry out that subtraction, just subtract the numerators. Hopefully that's pretty clear. That's just going to be negative pi over 3. So that's going to be my next answer. And if I do that arithmetic there, negative pi over 3 is going to be the other answer. And then I can go back to my identity again, right? If I have negative pi over 3 is an angle, well, if I have a negative angle that has a cosine value, the cosine of the positive is going to be the same thing as well. So I can say since negative pi over 3 works, positive pi over 3 must also work as well. So those are my three angles that I have here. I could also have gone negative 5 pi over 3 here and added 2 pi. So negative 5 pi over 3 plus the 2 pi or the 6 pi over 3, and that would also give me the positive pi over 3. So there's a couple ways you could do it there. All right, so that's kind of the basics. There's these two other problems here that I wanted for you to practice. If a problem is given in degrees, you can work it out into put your answer in degrees. That's kind of a good default. Stick with the units that you're given in the problem. If it's given in radians here, then put your answer in radians. So I've given you one of each to practice. So if you want to take a minute to do that, pause the video right here. And I'm going to reveal the solution in just a couple seconds. And so the solutions for number 2 are right there. The solutions for number 3 are right there. That's it.